Good morning, this is your Stat Sensei, Mr. Spensei, and this is a warm-up on exam scores. And by the way, I mean not a warm-up, this is the assignment for exam scores, and it's based on the warm-up. So in the warm-up, a college professor has 350 students in a lecture class. She claims the average score in the final exam is 75 out of 100. A random sample of 20 exam scores is taken, and here it is below. A dot plot indicated the exam scores were normally distributed. All right. And for our assignment, instead of creating a 97% confidence interval, it says conduct uh, a test at the 3% level of significance, in other words, alpha equal 0.03, to determine whether the final exam scores differs from the professor's claim. So the word differ is important because that lets me know I'm working with a two-sided t-test. So this is going to be a not equal to for my alternative. So our formula, x bar minus mu s divided by the square root of n. Well, previously I entered that data into the calculator. So I'm going to go stat calc 1 var stats, and I get a sample mean of 75.8. I also get a sample standard deviation of 1.5423. And they already said this was the claim, and that was my sample size. We're going to run a one sample t-test for means. So that part's easy. And you can just say one sample t-test, and we're good with that because that's how many samples we have. Yes, we have 20 data points, but we only have a sample size, but it's only a one sample t. That's all you have to have. Please remember, unlike confidence intervals are centered on X bar, but hypothesis tests are centered on the population mean. So this is centered on the mean of 75. And because it's a not equal to, this makes this a two-tailed test, which is what we have here. But our X bar is above the mean. So we have 75.8 as our X bar, as that's shown up here. But we also need to have an equal distance below. All right. So make sure we circle the not equal to. We can go ahead and run this test right now, but let's hold on just a moment. So the hypothesis, the mean is 75%. The alternative is it's not equal to 75%. And that's because of the word differs. Does it differ from the claim of the professor? So our sentence stem is the same. Let mu equal true population mean what? Score on the final exam. Conditions. Well, when I go back to my original, she said a random sample. Okay, random sample of 20, that was given. And if I take that 20 and multiply by 10, I get 200. And she has 350, and 200 is less than 350. So n is less than 10% of the population. And finally, although my sample size is less than 30, that failed. The normal distribution was given because they said that there was a dot plot. They told us a dot plot indicated the exam scores were normally distributed, so we were good to go because it told us normal was given. We could not use normal by central limit theorem. All right. So let's go ahead and run this test. So stat test, t-test, we have data. Our claim is 75. We have not equal. And we calculate. And in this case, we end up getting a t statistic of 2.3195 and a p-value of 0.0316. Now we have to be careful. Don't forget, this was a two-tailed test. So we need to put 2 times the probability that t is greater than. Now the question is, why is it greater? First off, if the t statistic is positive, use a greater than. The other thing is, we were above the mean. If we're above the mean, use a greater than. And we ended up getting a p-value of 0.0316. and 0.0316 is greater than our alpha 0.03, so our decision is to fail to reject. So our conclusion, our p-value is 0.0316, which is greater than our alpha. We fail to reject the null. There is not, we don't have enough evidence to claim that the true population mean score on the final exam is different than 75%. Now, please don't forget, different than 75% comes from right here. Different than 75%. All right? So really, when we're writing this up, the first part, our p-value is 0.036, which is greater than our alpha of 0.03. That's exactly what we have here. P-value of 0.0316 is greater than our alpha of 0.03. Then it says we fail to reject. Well, that's what we have here. And then we have there is not sufficient evidence to suggest that the true population mean score on the final exam is different than 75%. Different than 75%. All right. So all of that stuff in the conclusion is stated earlier as well. All right. Appreciate you watching, and I hope that helped. Thank you.